Students, I am Shubha. Welcome to our channel MATHWIZZ Academy. Since this channel is new, so I would request you all to get introduced to our academy and its objectives, clicking the link of our introductory video given in the description box. From now onwards, links of the earlier or relevant videos will be shared in the description box. Please follow them accordingly to build an integrated concept of the topic to be discussed. Likewise, before starting our new lesson on rational numbers, which is the first chapter as per the syllabus of NCERT or some other state boards for class 8, we should have a preliminary knowledge of number system. Since the inception of human civilization, conception of numbers had been an essential component of the then civilized people's day-to-day life, without which we couldn't reach where we are today. As the foundation of the mankind lies in the evolution of number system, before setting off our journey, we must have some basic ideas of the number system as a whole. Now, the questions arise, where did the idea of numbers came from and who were the pioneers? What are the scopes of these numbers? So, in this video, we will discuss these along with a brief introduction to different types of numbers, which will be elaborated in the subsequent videos. Regarding the evolution of number system, different mathematicians may not have the same opinion. Here I acknowledge Professor Robert Kaplan of Harvard University, who established his personal views in the context with some evidences in his popular book, The Nothing That Is, a Natural History of Zero. I have presented here the chronology of the evolution of number system in the timeline, where you can see in 3rd BC, Mesopotamians already had the idea of positional number system, then Mayan. But those ideas had been perfected during mid-5th century by Aryabhatta, an eminent Indian mathematician and astronomer, well known as the father of number system of India. He was the first person to use zero in the place value system. He introduced decimal positional number system consisting of 10 numerals with further conviction. In 7th century, Brahmagupta, who had been a contemporary great mathematician and astronomer, demonstrated the working rules for arithmetic manipulations that are applicable to zero and to negative numbers in his immortal citation named Brahmasphuta Siddhanta. He considered zero as a number in its own right, rather than simply placeholder to represent another number according to the Babylonian concept. But rest of the world could not accept considering it absurd until the German mathematician named Gottfried Wilhelm Leibniz, the first European, agreed upon and used this concept in a systematic way in his development of calculus in the late 17th century. Not only that, Bhaskara II, great mathematician of 12th century, had already discovered many of Leibniz's ideas over 500 years earlier. In his book Lilavati, he explained the properties of zero, including division by zero and other operations with zero. He had extensive numerical work related to negative numbers, arithmetic methods of multiplication, squaring, inverse rule of 3, rules of 3, 5, 7, 9, and 11, which you have already studied in your earlier classes. Bhaskara I, a pioneering mathematician and astronomer of 7th century, must be acknowledged for writing numbers in the Hindu decimal system for the first time with a circle for the zero. His most important contribution concerns the representation of numbers in a positional system using Brahmi numerals. Can you imagine, with respect to mathematical heritage, what was India's position at that time? We should be proud to be an Indian. Besides, much later period, good number of European mathematicians like Pythagoras, Adrien Marie Legendre, etc., contributed a lot in the field of development of number system. In this short span, history of number system cannot be discussed. In case of further query, you may contact through the email ID given in the description box. Now we will see that the entire positional number system is divided into 4 groups depending upon their utilities. Decimal number system comprises DECI, that is 10 digits 0 to 9, which implies its base is 2. It is useful for day-to-day activities and practice. Binary comprises by, that is 2 digits, 0 and 1, useful for electronic machines where 0 means off and 1 means on of electrical switches. Octal comprises octo, that is 8 digits, 0 to 7, which implies its base is 8. Hexadecimal comprises hexa, that is 6, and deci, that is 10, which implies its base is 6 plus 10, 16. Now, the octal and hexadecimal is useful for efficient memory management of computers. All the number systems discussed so far are interconvertible. According to the position of a digit in a number in different number system, value of a number is determined. Here are some examples. See, students, here what I told, that in decimal presentation, as I told, that suppose 234 is taken, and 2 is the 100th position, 3 is the 10th position, 4 is the 1 position according to the decimal number system. So you can represent, you can break it up in this. In the junior class, you have already learned 2 into 100 plus 3 into 10 plus 4 into 1. So here it is expressed, 10 being the base. 100 can be represented as 10 square. 10 is 10 to the power 1 and 1 is 10 to the power 0. As you know, from indicial form, anything to the power 0 is 1. So we write it in the 10 to the power 0. Now, if you expand 2 into 10 square plus 3 into 10 to the power 1 plus 4 into 10 to the power 0, of course, you will get 234. This number, this decimal number, you will be obtained. And next is binary presentation. Suppose we are having a number in decimal number system is 23, suppose. Okay, so if you want to express it in the corresponding binary form, it will come as 10111, and you know how these are actually formed, dividing by 2 and getting the remainders in the order. So we get it. Anyways, we will elaborately learn it in the computer science part, not in the mathematics part. So 1 into 2 to the C, according to the position, the leftmost one is the 5th position, right? So that is why it is written 2 to the power 4, like, and the rest, the rightmost one is your, that is the 1's position, right? Units position. So 1 into 10 to 2 to the power 0. Now, if you expand this entire expression, 1 into 2 to the power 4, 0 into 2 to the power 3, 1 into 2 to the power 2, and you sum them up all the numbers. So you will be getting this 23 in the decimal. It is very simple to find it out. Now, in octal presentation, we have learned that 8 is the base. See, 8 is the base, as I told, octal. So 234 can be converted into octal. It comes as 352. It looks very different now, but when you expand it, and calculate the value, you will get 234 only. See, 352 in the octal form, and according to the octal number system, the position of 3 is 100. So here, that is the starting from 253. 2 is 1's position, 5 is 10th position, 3 is 100th position. That is by 1, 2, 3. So what we write? 3 into 8 square plus 5 into 8 to the power 1 plus 2 into 8 to the power 0. If you expand it, if you just, after expansion, if you calculate it separately, you will be getting these 234 numbers. Similarly, in hexadecimal, as I told you earlier, 16 is your base. So the same way you can represent it. But one thing is there, the D is written here, 4D to 1, 2, 3, 4. The corresponding value in the hexadecimal form, it comes as 4D2. D means what? D means 13. As I told you, that in hexadecimal till 9th, we represent it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And after that, 10, 11, 12, 13. So 10 is A, 11 is B, like that. Okay, till 15 we represent, because hexadecimal contains 16 digits, so it will start from 0 and end at 15, as you know. So it is represented as 4 is the 100th position, so 16 to the power 2, because as you know, it is the n minus 1 form. So what is the position n? So it will be given, the power will be n minus 1. That way it is represented. Now, if you find the value after calculation, you will be getting 1234 in the decimal form. And each number system is can be converted into another with ease. Okay, so this much for number system. Now we proceed to the properties of numbers. Now, students, we are studying numbers. What are the different kinds of numbers? Most of them, see, here we find there are 4 kinds we have mentioned here, but it may go beyond. In higher classes, you will learn more and more. I don't want to actually spare your interest when you will be going to the higher classes. So that's why I'm not explaining the rest of the numbers which are already been there. Now, as per your syllabus, in till the 7th class, you have learned already natural numbers, whole numbers, and integers. Here we just will recapitulate those, and we will be introduced to rational numbers in this class. Natural numbers. So natural numbers, what are natural numbers which are naturally evolved? Why it is naturally evolved? Because as I told you, number system being the backbone of the the civilization, isn't it? If it is not so, if number system would not be evolved, nothing, everything would be stopped. No development in the science and technology. Okay, so that is why naturally it came into people's mind. So mathematicians named it natural numbers. Which are those counting numbers? 1, 2, 3, 4. This way it will continue as long as you can go. This is the highest number. There is no highest. So that is why when it is unknown, we represent in mathematics as infinity. You get the symbol. It is the Greek symbol. You are the lateral 8 type. So it is infinity. I have written there. And next comes the whole number. See, after natural number, I have written in W, Z, I, like that. No. So what is represented by those number, by those, literals? Just I will explain. When in mathematics, we consider the collection of same kind of objects, we name it set. So natural numbers means it is a collection of natural numbers, collection of same kind of objects. So that is why it is a set, and that is represented by literal n, suppose. In case of whole number is what? Entire collection of natural numbers plus 0 is introduced with it. So that is why now, including 0, entire natural number set is named as whole number set and represented by W. And here also the lowest number, the smallest number will be 0, highest is no end. As in the natural number, lowest is 1 and the highest has no end. But what are the integers? They are the whole numbers along with negative signs. So the negative numbers, introduction of negative numbers, I have already been told you. It was first, Brahmagupta and Bhaskara, one walked upon, and Bhaskara two elaborated on the use of negative numbers and all. So I have already told you. So in integers, you are finding that all the whole numbers along with their negative signs. So they are the integers and represented by the literal I or Z. Next comes the new concept, that is the rational numbers. In earlier classes, you learned fractional numbers, and you learned so far fractionals are represented in two ways. One is vulgar fraction and another the decimal fraction. And that decimal fractions occur in two ways. One is a terminating. Terminating means after decimal consideration, it will stop. Anyways, we will detail all these terminating and recurring decimal fractions when duly in the next classes, where we will be elaborating here, but just introduction is required. This is the scope of this video. So we will be confined within, not much discussion on it. Here, I'll explain it once again in the next video. See, definition. What is the definition? It's how the rational number is represented by the mathematicians. Okay, because rational number, roughly speaking, it is fractional, but it is not solely. According to the definition, mathematicians says that it is represented in the form of numerator and denominator. That is P and Q form. So P by Q. So you understand this numerator P and numerator Q, both of them have to be integer. Integer means positive, negative, anything. Okay. Moreover, the denominator Q should not be 0. Why it is not should not be 0? Because if it would be 0, according to mathematics, it is represented as an undefined number. So that is why Q not equal to 0 is to be considered. Along with P and Q must not have any common factor. That means P and Q, that is why they are called co-prime. Co-prime means they are prime to each other. They don't have any common factors. Rather, we can otherwise say that the HCF of P and Q will be 1. See, some of the examples had been given here, 2 by 3. See, 3 is the Q. It is not equal to 0, so you can consider it as a rational number. So 2 is, see, numerator is smaller than the denominator. Both ways it is possible. In 5 by 2, numerator is higher than the denominator. That is also possible. And in each case, you find 2 and 3, HCF of 2 and 3 is 1, 5 by 2, 5 and 2, the HCF is 1. Now, in case of negative integer, if we take in the numerator, either in the numerator or denominator, no matter, they represent as this. See, minus 6 divided by 7 or 6 divided by minus 7. They are all equivalent to minus of 6 by 7. That is also possible to take. And here we will check that 6 and 7. 7 is the denominator, which is not equal to 0. 6 and 7, their HCF is 1. So I think you easily understand what is meant by rational number. Now we will proceed further, and we will, in the next video, we will discuss it in detail. Now students, please check here. I have represented all these ellipse, concentric ellipse. So here, every ellipse represent a collection. The innermost, which is the smallest, that is your natural number. And next yellow one, that is whole numbers. It is represented by W, and it contains the natural number. That means extra 0 is there, no? 0 is included along with natural numbers. So it will include that means W will contain N. So in such case, see, each and every ellipse which has been represented here, N, W, Z, Q. So they are the sets, and this diagram is called Venn diagram. Afterward, in class 11th, it will be introduced to you. Now here, just to brief it, I would like to say here I have written already. N means natural numbers, W means whole numbers, Z is integers, Q is rational numbers. Here, one thing I must tell you, the smaller set, which is content within a bigger set, the bigger set is called superset, and smaller set is the subset. Now, why I am saying all this superset and subset, which you will already be introduced afterward. So that is why the reason being that I want to tell you that properties of the subset is carried by the superset. Superset can have some extra properties which may not be carried by the subset. So that is why any property which is applicable for natural number, it is applicable for whole number, that is Z, your integers, rational numbers, because natural number is content within them, no? So that is why. Similarly, the characters or the attributes or the properties of whole numbers are applicable for the Z, that is integer, set of integers. Likewise, the properties of integers will be carried by rational numbers. So that is why I am saying so. When I will talk about the properties of these numbers, then it will be clear to you. The reason being, okay. So now I would like to say, so this much is the relationship among the numbers. There are some more numbers also, you will learn later on. So as I told you, that I don't want to kill your interest further, because afterward when we learn and it will be new to you, it will be more interested. So that's why, but there are certain number sets which you will be learning afterward. Here I am not mentioning them. I'll mention all those in due time. Okay, then bye students. So along with this video, I must tell you that if you like this video, if you feel that it can be improved more, please comment. Your valuable comments will help me or help us rather to help you in a better way. In which way? Because we can improve, we can incorporate, or we can eliminate some of the part which you feel that it is extra. That way you can say. And moreover, if you like it, press the like button and share it with your friends. And of course, subscribe the channel if you have not yet subscribed it. Okay, so in this way, if we move forward, then if you follow all the videos sequentially, you will. I can guarantee you that you will have a very nice concept, very good, strong foundation in mathematics, basic mathematics knowledge. Okay. So good day, students. Bye.